The final topic here is piecewise defined function, kind of like this. When x is less than or equal to -1, first line. When x is greater than -1, the second line. So we have a possible breaking point at x equal to -1, and we have to define a and b values so that this function is continuous and also differentiable. Okay, how about the continuity? You simply plug in x equal to -1 to this one and that one, and they have to be the same. Basically, we have this f of -1 equals to, and the limit, the left-hand side limit, and also the right-hand side limit. This should be minus, and that should be plus. Okay, basically this is the continuity condition here. X equal to -1 directly, and then for the left-hand side and the right-hand side. In this particular case, these two are always the same because equality is included in the first line. Now, if you have three lines here, less than -1 for this, greater than -1 for that, and then another condition, third line for x equals to -1, in that case we have to consider all three. But in this case, we have to consider only two lines. First line, oh come on, the first line are these two. And the second line is the third quantity. Okay, and let's set all these equal to each other. Okay, and at x equal to -1, so I have to plug in -1. And then x equal to -1, and that too has to be -1. And this one came from the first line, and this one came from the second line. So what do we have? We have equation number 1. Next, we have to consider the derivative. Slope here and slope there have to be the same. So how do you find the slope from here? Left-hand side slope. Take the derivative, and 2x plus 2a, that's coming from the left-hand side. And the right-hand side, 3a x squared minus 2b, these two have to be the same. Let's see. Basically, I'm doing this. There you go. So left-hand side derivative and the right-hand side derivative are the same. In order to have left-hand side derivative, x has to be what? -1. Right-hand side derivative, x equal to -1 to the second line. And this one came from the first line, blue, and this came from the second line, red. So what do we have? We have two equations and two unknowns. We can solve it. Actually, I have a feeling that, yeah, this will give you one of its own, and this will give you another separately, so that this problem is a little bit easier than general case. But in general, it goes like this. We have one equation from directly plugging in the continuity with another equation from the derivative. and then plugging in. So we have two equations and two unknowns, and you can solve. That's a little bit more general case. Let's go to this problem. Let's see, what do we have here? We have 1, negative 1 squared is 1, minus 2a plus 2b equals to, let's see, negative a plus 2b plus 2. That's what we have if you simplify a little bit, isn't it? And then please note this 2b here and that 2b here are common, so we can just cross those out. And you're going to get, let's see, 1 minus 2a is equal to negative a plus 2. Flip this a to the other side, so negative 3a equals to, flip this one to the other side, we have 1. A equals to negative 1/3. So we get a value from here because these two canceled each other out, luckily, and then we just got this a value directly. And then from here you can find b value. Let's see, that's negative 2, and then that's positive 1, and then this is okay. From here, another one here. Yeah, from here we can find out b value as well. Let's see, what do we have? Multiply 3 to each, so negative 6 plus 2 equals to 3 minus 6b. I hope my mental math is correct. I don't know. I don't think I did it right. I cannot trust myself. I'm supposed to get 1/2, not 7/6. So there must have been some algebra mistake somewhere. Okay. I think there was an algebra mistake here. A should be negative 1, and I get negative 1/3. So obviously there was a mistake somewhere. Let me see. Yeah, here, if I flip this one over to the other side, I don't get negative 3a, it's just negative a. So this is just a equals to negative 1. Right here, if I add a to both sides, then minus 2 plus 1. So minus a equals to 1, so a equals to negative 1. That's what I should have got. And that should be negative 1 there. Then maybe everything works out. Negative 2 minus 2 equals to negative 3 minus 2b. Yeah, okay. Everything fits. So that's how you get these two problems done. But as a matter of fact, and the tedious numerical computations are not that important. Let's come back to what is important. Plugging directly x equals to negative 1 and checking left-hand side and right-hand side are the same. So left-hand side limit and right-hand side limit are the same. That's going to give you equation 1. Here, blue is left-hand side and red is right-hand side. Now, taking the derivative and plugging in x equal to -1. So we have left-hand side slope and right-hand side slope are the same. Here, blue is again left-hand side, red is right-hand side. So what we have equation number 1, equation number 2. Two equations and two unknowns a and b. With these two, we can find out what a and b are. That's the general method, and that's a method I'd like to suggest. Is that what I did here? Yeah, basically. Set left-hand side and right-hand side equal to 0. They equal to each other. And here again, yeah, left-hand side and right-hand side equal to each other. So we have two equations, two unknowns, and then some tedious computation. We can find a and b. Okay, so much for the practice exam problem set. And the real exam problem set will be pretty much comparable. There are some problems that you have to see, like limit and limit rules, and derivative problems and tangency problems. Those are really absolute. And there could be some graph problems or some tables or something else. As for piecewise defined functions, those are wildcard problems. You may see some very different types of problems, or maybe not. In any case, I hope this was a sufficient review. Thank you. Everybody, good luck.